Okay, hello everybody. Here we have the last application we have developed with ThreeJS. Let's see the status. So if you actually again go on the folder of your project and then so you open it with the browser, for example Chrome. So that's what we have, and then remember we actually set keyboard to change the resolution of this Moebius strip. So now we are trying to adding models to the scene. So let's see how we can add some model to the scene. For example, let's first download the model. So my suggestion is you can go to for example Turbo Squid, okay, and then let's say I want a model of an animal, and then you actually want to select the one with lower price, and then for example you select I don't know, let's say like this crab, which is really nice. Okay, and I download, and yeah, the obj is right format. Okay, so you can download it. It will take a while. Okay, it's going on. Almost finished. It's gonna be a big model. Almost there. Okay, here we go. So sometimes when you download an obj, it changes the extension to txt. So just change it again in obj if this happens. Okay, so if you want to see, okay, it was already there. Yeah, I already downloaded. Okay, so if you want to see the model, then you can open with MeshLab, and then actually you will see the model is pretty huge because maybe it's a scanned model in this case. So, and then maybe we'll lower down the whole application. So what you can do in this case, you can actually use decimation, and here you set the number of phase. For example, let's say like 50 1000, okay, and then you want to check these things, so it will take a while, and then it actually decimate to lower resolution. You have to wait a bit because it's supposed to be 2 million face at the beginning, so it's coming back to 50,000 face. Okay, done. And now, as you can see, the mesh seems the same, but the resolution is much smaller, the amount of triangles here you can see. Okay, so let's export the mesh in your project folder. For example, I have my folder on my project folder, so it's like so let's save on the desktop and then I will move. Okay, so I call it crab simplified. Okay, and then you can save both in obj and ply. I have the importer for ply, but you can see ThreeJS it also support obj file. Okay, save. You may want to don't save per vertex color, it's fine. Okay, that's fine. Let's try if the mesh it's okay. So I have this mesh here. Let's open again with MeshLab, and then you can see here, you see your mesh, right, of the crab. Okay, good. Now let's move this this mesh in the project folder. So I have my project folder, so which is here. Okay, my project folder, this one. So I go to models, and then let's put the crab simplified. Okay, good. So now let's try to import this model. Okay, so first of all, what you have to do is add the model loader. So this is ply loader.js, which is the JavaScript module to load ply files. Then you have just to include here. Okay, and then here I actually copy my code from the old application, and you will see that there is a part where I load the mesh. Okay, so I copy this here, and then let's see that I don't want to visualize the sphere, so okay, so what I have to do is like I comment the sphere geometry, and I call like let's call it crab color, and let's call crab material, and then actually crab material dot color, crab material shininess, and then let's comment this out. Okay, we don't want any emissive component, and we don't for now let's avoid shadows, and I don't want to add this sphere, but instead from this previous model I want to add the crab mesh. Okay, so then I copy this part, so I create the loader for load ply, so I create the mesh with by default is null, and then it's I set the path of the loader. So let me save, and then if I go here and then I copy the name of the file which is in the directory, and then once I load, So let's comment this out for the moment. So I will show you the effect of this uh, actually instructions. So what I have to do is I have to create a mesh. So let's comment until here, right? So I create a mesh. So this function, it returns me a geometry, which is a bunch of triangles and the vertex we have seen in the lecture. And then I create this mesh with the geometry. And then I actually, let's comment this for now. And then I give a name to the mesh. And let's comment this for now. And I just add straight, right? I have the material, I have the color, I have set up a fog material with shininess. I hope you remember what is it. And then I load. Okay, let's see what happens. Okay, so I save it, I go here, and I take my application, which I just modified, and I load here. So nothing happens. There's maybe some error, so you can view developer tools, and then what it says, like, okay, this is something not defined, so maybe I did some error. So it's crab color. Okay, good. So let's come back here and check it again. Okay, so when you have these errors, so first of all, there is a sphere mesh somewhere, and it's at 133. So let's see, 133. No, it's sphere mesh is not defined. 133. Okay, 133. Okay, so the spotlight target, it was referred to this old mesh. So as I remember, you can actually let's call this crab mesh. Okay, and what you want to put the light instead of the old sphere on the crab mesh. So let's change the name of this variable. Okay, now let's see what it says. Okay, so it actually cannot load the mesh because there is a firewall in the browser preventing you load data from the current context. So what you have to do, what I do, it's actually I open a terminal, and then you go in the folder of the project, and then you start a PHP server. Okay, there is also a similar solution on Windows. You can Google it. And now what you have to do is just you have to go to this path, right? And there is some other error, so which is matrix to word null, and so it seems like it cannot read the model. So I suppose that I'm doing, so let's comment this one. So there should not be here. Okay, so there should be still something. Okay, okay, material is not defined on 107. 107, indeed it's crab material. Okay, okay, so let's comment also this out. I will explain you why. Okay, mesh is not defined, 110. Okay, let's see what is the error. Okay, 110, it's crab mesh. Okay. Okay, now we have our crab. So why it's this way and you don't see the shadowing? Well, simple, because you actually didn't load the normals for this one. So we can actually try to compute normals. So you just have to make call this function while you load the model, and that's it. So let's try again, see what happened now. Okay, now you have your crab, right? It's a bit huge, so maybe you want to resize to fit the size of your application. So if you remember like the size, so what you can do is, like, because you don't know the size of your object, what you can rely is a bounding box, which is a box that is aligned on axis, whose size is a size that contain the overall object. So what you can do is, like, let me comment out these things, right? So so what you can do is, like, you can get the size of the bounding box and then define a scaling matrix, right, which is scaling uniformly by something which is dependent on the length of this bounding box size, which is a diagonal that goes from the lowest vertex of the bounding box of the higher vertex. So bounding box is a box that contains the overall object, okay? So we don't need this, okay? And then what we do is, like, we apply a scaling matrix, apply matrix, and then we apply this scale, okay? Sorry. Okay, let's see what happens if I do so. Okay, so it's better if you want to scale it more, so you just have to reduce this, for example 10, okay, and that's it. Okay, so you maybe want to rotate by 90 degrees, so you can apply another, so let's make it smaller again. So you may want to rotate by 90 degrees. There is several ways to do so. So you can define a transformation of rotation in this, or you can actually modify the mesh in MeshLab, and then like import in a different way. Let's try how to do so. So I open with MeshLab, right? And let's say that is this way I want to rotate that it looks on me. So rotate, and then you have to rotation along the x-axis of 90 degree, okay? If you click on preview, so let's see how it goes. Okay, perhaps you want to rotate of minus 90. Sorry, you have to do like this, minus 90. Okay, so here how it is. So, and then you have to click freeze matrix, apply, okay, close, and then you save. Okay, let's see what happens here if I reload it. Okay, now my crab is like this, right? You may want to rotate also on the other side, it's up to you, okay? So okay, so you may notice that the crab is already in the center, but if it's not in the center, what you can do, it's like you can define, you can get the center of the bounding box, then you can define a translation matrix, okay, and then you can center the bounding box to, you can get, this is a point, which is the center of the bounding box, and you can translate the center of the bounding box to the 0, which is, or whatever you want, which is actually the center of your scene, and then actually you can apply this translation after you scale it. Okay, let's see if it works. No, because I actually applied in the wrong way, because I first translate. Okay, I have first scale and then translate, and it applies in the other direction. Okay, now it's in the center of the scene. Okay, when I do so, you remember always, like, the last one is the first one to be applied because it's actually applied in a reverse order. Okay, now yeah, actually it first translates the object into the 0 and then it scale. Okay, so it applies in this order. If you actually combine the matrix, it's the other way around. So you have to combine first with scale and then translate, and you get the same result because it multiplies the matrix, right? It's just a matter of changing the order. So because if you scale when it's translated, then actually you actually change also this position, if you remember how scale depends on translate. Okay, now we have the crab. So let's try to actually, first let me change the color because I don't like that much. So I want to be more reddish. Okay, and that's it, right? Much nicer. Okay, now what I want to do is, like, let me put the light. Okay, and what happened, it's like let me put back the light. Yeah, so if you see here, so there is an error, and essentially because you are trying to put the light on a mesh, but the mesh is not loaded yet. It actually, this one, it continues loading, and it will actually go and execute this instruction before the crab mesh is instantiated. So there is two possibilities to do so. For example, you can actually put it in the resize function or update loop and see if this value is not null. So when you actually load the model, right, you can check if this is different than null, then you do something. For example, let's put like this, right? So we have let's wait for this, and then copy this instruction here, right, on my update loop. And what I have to do, it's like if crab mesh different than null, then it actually set the target of this light and then add the light to the scene. Okay, and of course I have to do it only once. So let me bool added, sorry, var added crab equals to false, right? And added crab and not added crab, and then added crabs equals to true. I only do only once. Okay, let's see what happens. Okay, there is something wrong. Okay, no, there is something wrong here. Okay, so now it worked. Okay, so we also have a light from above. Let's see if it worked out. So let's, for example, disable the camera light to see if I actually added the right. Yes. Okay, let's try to disable this. Sorry, and see if I still have a light coming from above, because otherwise it's difficult to see. Okay, yes, I have some light coming from above. Then we will add the shadows and everything. Okay, cool. Okay, so now what we can do, it's like try to re-add again the shadows. For example, the crab cast shadows means like the crab produce a shadow, and then actually I actually have to set it here. When I actually load the model, when I actually create the light, I have to say that the light produces shadow. So it was like this. Okay, and then let me put again the point light. Okay, he's here. Okay, and here we are. Okay, there is something, error 110, which is again like a wrong name of the variable. Okay, good. Yes, nice, right? We have our crab. So we can still redo the animation on the crab, and of course there's still like this that works, right? I can animate the crab. Let's see if I can put the other animation that I was doing on the sphere on the crab. So I can like so obviously I can animate only when it's loaded. So it's crab mesh. So then what I have to do is if added, okay, crab. So if I added my mesh, what I can do is like I start changing this value, right? And then I can do let me copy this, and then crab mesh dot position, and I change also the position on Z, right? And what happened is this, the following. So the crab is moving, and I can obviously rotate, or let me move it slower, okay? And then I can rotate and whatever, right? Okay, so for example, like I can like try to yeah, rotate around some axis, and yeah, and this is the result. Okay, it actually moves, and you can see also it rotates, right? Or you can rotate around X. Well, anyway, so this is you can compose, and you can also write your rotation matrix as I explained you in the previous lectures. Okay, so now what we can do is like so let's see how, if I want to define my terrain with a different mesh that I want to put like a mesh defining triangle by triangle. So let me copy again my code from there. So as I explained, a mesh is a bunch of vertex which are interconnected by triangle. So in this case, I can actually create the mesh by setting triangles, and that's very important if you want, for example, to create some noise function or perturb your terrain to create some particular effect. So I'll copy this one and let me add somewhere here. Okay, so okay, let's put it here. Okay, what this does, it's actually and I comment and I explain you this function, and I also need this function here. Okay, okay. So what I want to create is I create a grid of vertices. So I create the floor. So the size of the floor is 40, and then I subdivide it 100 times. So I means I create a grid of 100 by 100 elements on the floor, and then the step is like the size of the grid divided by the number of subdivision, right? So I want to create a grid of triangle 40 by 40 subdivided 100 times. So I create a new geometry like this, empty, without anything, and then I actually, for each subdivision along each sides, so you remember it's like 100 by 100, so I create a new point which I variate along x and z, right? So y it remains 0, so then I actually create the position of the vertex, and then I actually the position of the vertex, first of all, I have to create this vertex, which is at position minus. So the position of this vertex is the position on the grid, which is the index times step and the y times step. And then I actually, let's comment this for now, okay? And let's comment this for now, okay? And this for now. So then I actually add the vertex to the vertices, right? Then you add the vertex on the vector of vertices of this geometry. So the geometry has a vector of vertices, I explained at the lecture, and then you actually try to connect these with a grid, okay? So you know the order where you added, so it's a vector of vertices, so you actually find the position of the vertex on this grid. So I have this function access grid that tells me like the vertex ij, which is the position in the vector, and it's like x times the number of subdivision plus y, because the grid is ordered in a set of like vectors, one after the other, so lines after lines. So given those, I can get access to the vertex. And then I create for each quad, like for each 4 vertices, like 2 triangles, and then I compute the normals, then I create the material, and then I say like this is double side. I let me comment this for now, and I will explain how it works. And then I change the position, and let me comment this for now, okay? And then I give a name to the mesh. It's possible to give a name to the mesh to actually refer them during the computation if you want to do some computation on a particular scene. So let's now erase the box geometry that I have on the ground, because so far what happened is essentially nothing, right? Because I didn't call this function. So let's remove the box geometry of the floor. and which supposed to be, yes, this one. Okay, so I comment this, and then I actually, okay, so if I comment this, what happened is this one. Okay, I don't have the floor anymore, and I want to like add a new floor, which is like this one, create floor. Okay, good. Let's see what happened. If I'm lucky, it works. Yes. Okay. So it actually it created the, because the 0 is here. So if you see, I always like increment and decrement the index. So it's actually started creating from 0. So what I have to do is like translate the overall thing on the 0 here. Okay. So another thing that I can do is like maybe move a bit down. So these things. So what you want to see, it's maybe if I actually what I want to see, it's like wireframe equals to true. If I do so, you can see the triangulation we created. You see, like we created a triangulation. Okay, okay, good. So now what we can do is like remove this wire. Okay, and then I want to move by this to the center. So I actually let's move this by, okay, by this. So I have to add to the position a vector that move back to the sides of the element divided by 2, because it should put in the center. Okay, and then if we reload it, okay, nothing. Let's see why. Oh, okay. Minus signs. Yes, because I actually added pos instead of post trans. Okay. And then if I load this, yes, now I have it centered. Okay. Okay, now it's a bit big. Maybe let me move a bit down, so you can add like -10 here or -5. Okay, and then you have your ground. Okay, so now because I defined the vertex by myself, I can actually define every kind of function along y, which can be, for example, like this y value. Okay, so for example, let's say like I actually use a sine function. You can define your value as you want. So if you now load it, so what happened, you will have something like this, right? So let me move a bit down and let me reduce the size of the thing. So let's put the size 20 and let put a bit down. Instead of -5, let's put -10. And here I can increase the period of the sign. Okay, and that's it. Oh, it's bigger. Yes, because I didn't actually okay, I did the opposite thing. Okay, now you see it's like it has the shape of a cosine function, a sine function. And what I can do, it's also like try to increase the period. Like if I multiply this by 5, maybe if you remember, like about sine and cosine things, that should increase the period. Yes. Okay, maybe it's too much. Let's multiply by 2. Okay, good. Yeah, you see, let me move a bit down. minus 20. Okay, anyway, so you can actually use whatever kind of sorry, this doesn't change anything because afterwards I change the after I change the value of y directly, while I have to put this y val here, okay, and this is the amount I translate by y, okay, so then I can do minus 10, which is a constant, and then I actually yes, and then I actually add this value to post-trans, and that should works straight. Okay. Oh, something wrong because I maybe composed the transformation in wrong manner. So yes, I move it and then I set the y. Okay, what I can do here it's y minus 10. So this way it should work, because first I define the sine function centered on 0, then I move down. So yes. Oh, sorry, I think I actually changed it. Yes. Okay, maybe I move it too much. Let's move by 5. Okay. Okay, again, this is an example. You can actually change your your like function of vertex function, like for example to create a terrain instead of sine you can create a random function. I think there is a way. For example, let me Google rand JavaScript random function. So yes, there is math random. So yes, it gives you a number between 0 and 1. So if you can, for example, if you don't want to perturb along this, you can do like math.random and multiply times 0.5, okay? And then what you will have is it's like this, right? Okay, and of course you can generate better like noise function. You can just have to Google. There is some noise function to generate terrain. One very good is called Perlin noise, and you can implement it if you want to generate terrain. And yeah, this is all for now. I think the only thing I have to show is that if you go like this, that you don't see anymore the ground. So what you can do is like you can actually do that, put the material of the floor double side, and then what happens is like this. Then you see from above and you see from bottom. Okay. Okay, another thing that you maybe find interesting for your project, it's like how to select an object from the scene. So, for example, I want to select one of these cube, or I want to select the crab. So what you can do, it's like you can use the raycaster. So what you have to do, it's like define this raycaster. Okay. you can add it somewhere. Of course, structure your code in a proper way. So I'm doing this for just to show as a demo, but divide it in module, make it readable, because you have to present it by the last lecture, which will be like week 11. And then the raycaster is something that when you actually click on the object, it gives you like a list of the objects that are visible from the camera, and it gives you like in the order of the direction of the camera. Okay, so for example, let's say like I copied all this code. Okay, you can do the same from my examples. What you have to do is like when you have to link the mouse down events to one function, okay, which is on document mouse down, which is a function that you define. Remember that you can actually have this very useful function, which is console, with a log that you can print message for debugging usage, for debug your application in general. So you get your coordinates of the mouse. You can get this for free. This transform the coordinate of the mouse from the rendering context to the screen context. And then you set the raycaster and you say, okay, I'm using the mouse and from this position of the camera. And then you actually call this intersect object, okay? And this tells you if it intersects some object or not, okay? Let's change this one. And if so this actually it returns you like a vector, and on each vector you have the mesh that intersect the raycaster, right? And for example, you can actually get the first one. Here you can check by name if it's the crab model or everything, right? Let's say if I want to able to click only the crab, or yes, then I actually get the first element on the intersect rays, and I set and I change his material to basic material to show what does it change. Okay, so if I actually load now, let's see if there is an error. It seems like there are no errors. So if you actually click, you see the element, it becomes like white. Okay, so there is some warning. Maybe you can check, because I mean I'm changing the materials of this one and it doesn't have these properties. Okay, so that's what happen if, for example, and notice that an important thing is like because I added the name. Okay, so if you actually click on this or on this, nothing happens, right? This one happens, right? This other happens because I didn't set the name for this one, or yes, I added the same name for the floor, so let's call it floor mesh. Okay, so then if I do want to click on the just on the cubes, right? Then I actually add two different if. Okay, and then let's see what happens in this case. So then if I click here, nothing. Here, you see. Okay, when I change it, of course you lose the clicking things. Okay, I think this is all for now, and I think you have enough things to actually continue and work with your application, loading models, simplify, interact with it, and that's it.